So now we move on to aromatic hydrocarbons. So far, everything we've talked about have all fallen under aliphatic, okay? And so our distinction, or our two different types of compounds, are aliphatic and aromatic. For something to be considered an aromatic hydrocarbon, such as the ones on this slide, they have to have a benzene ring, okay? So as soon as you have benzene, that is what makes a molecule aromatic, okay? So you see benzene, it's aromatic. No benzene, it's aliphatic. That's kind of your distinction between those. So three different ways that you will see benzene molecules drawn, okay? This last one is definitely the most common, okay? It's your hexagon with a circle in the middle. Okay, these are two other alternative ways of drawing benzene, and they definitely do on occasion draw them this way. It's kind of hard to see, but you can see here it's a double bond, then it's a single bond, then it's a double bond, then it's a single bond, then it's a double bond, and then it's a single bond. Okay, and this is the same thing, it's just kind of rotated on its side. But this is definitely the more common way of seeing it drawn. So, if you have benzene inside of your molecule, it's aromatic. No benzene, it's aliphatic. So, your general formula for benzene is C6H6. Okay, and the reason for that is if you think about this, right, if there's a carbon here, and here, and here, and so on, and each one has a double and a single bond going to it, that means there's only room for one hydrogen, right? So there would be one H hanging out here, and there would be one here, another here, and here, and here, and then one up here, right? So that's why it's C6H6. That also means that anytime you get given a formula and you see that it's C6 with an H that's either 6 or less, usually that's going to be a pretty solid indication to you that you're going to be drawing benzene, right? If you think about the general formulas we talked about for our alkanes, alkenes, and alkynes, they were like CnH2n for the most part. And this isn't even remotely close to 2n, right? Like these are the same number. So as I'm talking about that, that reminds me that when we talked about cyclics, I didn't give you a general formula for those. Okay, if you think about how a cyclic is, it's going to have the same general formula as an alkene. It's going to be CnH2n. And the reason for that is by not having those two terminal carbons, right, the ones at the end of the chain, instead we've linked them together, that means we've lost two H's, okay? So please be aware and make note somewhere that your cyclic compounds have the same general formula as an alkene does, okay? Okay, so naming aromatics. There is two ways to name an aromatic. Okay, what it basically comes down to is benzene the main chain or is it not the main chain? Okay, so if it is the main chain, then the root and the suffix are together and they're simply benzene. Okay, so if we say that we have benzene, you automatically know you're drawing a hexagon with a circle in the middle of it. If there's any side chains, then those are going to get placed into the prefix. Okay, numbering wise, similar to our cyclics in that if there's only one thing attached to benzene, I don't need to provide a number because it's automatically going to be at number 1. If there's multiple things attached, then we're going to follow that order of priority to assign number 1, and then either we'll go clockwise or counterclockwise, depending on which way makes the most sense to give us the next lowest number, okay? If you look at these highest priority groups, those are some groups we haven't talked about yet, but you'll see that we will get into those as we continue going through the groups, okay? But right now, from what we have covered, order of priority, we're not worried about triple bonds or double bonds because those are already incorporated in what benzene is. So right now for benzene, when we are naming aromatics, our order of priority is just alphabetical order for side chains, nothing more than that, okay? So where you have this second option for naming, it's coming in down here, okay? So when you look down here, it says if the benzene ring is attached to a hydrocarbon with more than 6 carbon atoms, the benzene is then considered to be the side chain. Okay, the reason it's considered to be the side chain, a root should always indicate the longest carbon chain. Benzene only has 6 carbons, so if it's attached to something with 8 carbons, then it's not the root, right? That 8 carbon is the root. So if that happens, benzene goes into the prefix, gets incorporated with all those other side chains, and it has a specific name of phenyl. Okay, I know it's weird because you're like, well, why wouldn't it still be benz? But it's just not. It's phenyl. Okay, so you need to be aware that there's 2 ways to name benzene. One is just as benzene in the root and the suffix. The other way is to pop it into the prefix as a phenyl. I'm only going to do that in 2 cases, right? And those 2 cases are that it's attached to something with more than 6 carbons, or that it's attached to something that has a double or triple bond. Because remember when we talked about alkenes and alkynes, we said that those could not be in the side chain. Okay, so those are kind of our exceptions, and we will look at a couple examples as we go through this. That's going to show you what that looks like. Okay, so here's our first example, this one over here on the left. Okay, so you can see that we have benzene in here. Our root and our suffix are going to be benzene because these don't have double or triple bonds. And 1, 2, 1, 2. They both only have 2 carbons, so they're not going to be more important. So that means my root name for this one is going to be benzene. Okay, numbering wise, either this is going to be 1 or this is going to be 1. It's going to come down to order of priority. They're both the same, right? They both have 1, 2 carbons and 1, 2 carbons. So because they both have the same number of carbons, they're both ethyls. So it doesn't matter which one you choose to be what. You could choose to go 1, 2, 3, or you could have done it the other way and made this 1, that would still be 2, and that would be 3. But ultimately, they would still have those side chains at 1 and 3. So because they're the same, we're going to group them together. 1, 3 dash, because there's 2 of them, di, and then because they each had 2 carbons, ethyl. So this is going to be a 1,3-diethyl benzene. Okay, now we look at this one. So again, same deal. It's still going to be benzene because this is only 1, 2, 3 carbons, and this is only 1. Okay, so if we think about what these guys are called, this is a methyl group. Because this one has 1, 2, 3, it is a propyl group. So numbering wise, we have to decide if this gets to be number 1 or if this one over here is number 1. So if we think about our alphabet, M comes before P, which is why this is going to be number 1. Okay, it doesn't matter if you go clockwise or counterclockwise, you wind up with that same number of 4 down here for that propyl. Okay, so full name wise for this one, we're going to go alphabetically. So it's going to be a 1-methyl-4-propyl benzene. Okay, and all one big messy word. Okay, so I wanted to give you an example showing you something that's a little different, right? So here we still have benzene. I've drawn this one a little bit differently in that I put the single double bond alternating. And then we have this side chain over here, right? So I call this the side chain, but if you actually think about it, this is not the side chain. And the reason this isn't the side chain is this has a double bond in it. And so what that means is that this is actually my main chain, right? So this is my main chain, and this is my side chain. And that's because I have a way to name this as a side chain. I don't have a way to name this as a side chain, okay? So 2 carbons over here, at which point could I number them? Sure, I could say that this is 1 and I could say that this is 2, but I don't actually have to number them because even if, let's say, this benzene was attached to this guy over here, it would be the exact same thing. It would just be flipped over, okay? So my root in this case, because I only have 2 carbons, is eth. My suffix, because I have a double bond, is ene. Okay, again, I don't need to put a 1 in there because there's only 2 carbons, so there's only one spot for the double bond to go, and that's smack dab between them. So how we're going to name this benzene is we're going to put in the prefix as a side chain. So because we're putting in the prefix as a side chain, though, we're not going to call it benzene. We're going to call it phenyl. Okay, so phenylethene is what this guy is called. Okay, and it's not a benzene with the eth in the prefix because we don't talk about how to name side chains that have double bonds. So in this case, this was more important, and that's why it had to go here, and we had an alternate name for that benzene that allowed for us to put it into the prefix. Okay. So physical properties of aromatics. As you can probably guess from the name aromatic, they have a strong aroma. They smell. Unfortunately, these don't smell nice. Probably the only aromatic compound that you've really ever had contact with in your life would be a mothball. And most people don't associate mothballs as a pleasant smell. They have a very strong, characteristic smell, and that is true of aromatics. Okay. Boiling points, we don't really talk too much about boiling points of aromatics. They're somewhat similar to aliphatics based off of how many carbons they have, but their patterns and trends are very different, so we really don't get into that. The one thing, though, that we do talk about is their solubility, okay? So when it comes to the solubility of aromatics, right, so far we've kind of just said that everything has been soluble in hexane because like dissolves like. But if you think about aromatics, they're not aliphatic, okay? So what you're going to find is generally when we talk about aromatics, we're looking at the solubility in benzene. Okay, you're going to find that our 3 major solvents that we tend to talk about are going to be water, hexane, and benzene. So when it comes to the water, things that are going to be soluble in water are going to be molecules that are polar. We haven't dealt with any of those yet, right? And things that are soluble in hexane are generally going to be aliphatic, whereas things that are soluble in benzene are going to be aromatic. Okay, so those are kind of your 3 major solvents: water, hexane, benzene, and they each dissolve, or I don't want to say dissolve, they each have miscibility with different types of aromatic compounds, or if it's not aromatic, it could be aliphatic or something that's polar.